You're watching NASA Edge.
An inside and outside look at all things NASA.
We're here live at Vandenberg Air Force Base at the Spacecraft Support Complex, which is about 11 miles by car from the Space Launch Complex 2, where OCO-2 is on the Delta II preparing for launch.
Yes, the Oribiting Carbon Observatory-2. It's going to be the first NASA remote sensing satellite that's going to be studying carbon dioxide.
Yesterday afternoon, I had an opportunity to go over to Space Launch Complex 2, and while I was over there, I had an opportunity to run into NASA Administrator Charlie Bolden. And he is actually just off set right now and will be our first guest on our show.
Kind of tell us from your perspective the importance of this mission.
It's critically important, not just for NASA and the nation, but for the entire world. It's the first time that we're actually going to be able to look from space and take very detailed measurements of carbon dioxide output, but also what are called carbon sinks. Where's the carbon going?
Right.
And those are questions that we hope will help us understand changes in the environment and the like. Since we believe that CO2 is the big greenhouse gas that's contributing to most of our problems right now.
I understand that you've been following this mission closely. You've been to some of the facilities. You actually had a chance yesterday to be right next to the Delta II.
We actually were out on the pad prior to rollback,
right,
and they let us go up on the pad itself. And it was really interesting to have an opportunity to look at the various components on the rocket and have the technicians, the guys that work at it every day, tell you what they were and everything. You know, we don't get to see a Delta II very often anymore. We're going to launch this, and then we have 3 more flights on the Delta II before the inventory is gone, and unless there are some other customers out there,
right,
then these are going to be the last few flights on a Delta II. And it's been an incredible vehicle for ULA.
But the Delta II has had a great track record. It's a very successful rocket, and it's launched many spacecraft into orbit.
I like to say it's a launch vehicle that has a sweet spot for medium class payloads. And I learned this yesterday, it was one that was ideally suited for global positioning system satellites, and over time they've grown in size and complexity, and so they kind of grew out of the Delta II class, and it leaves just like our Earth science missions that are just the right size that fit in the sweet spot for a Delta II.
John, what is your role here at Vandenberg?
Well, so there's a small group of NASA employees and then a support contractor that supports us. We have several facilities here on Vandenberg Air Force Base, including the Space Launch 2 Delta II Launch Complex, and we are Kennedy Space Center employees, and so we manage and maintain the facilities here for the launches that we do off the West Coast for NASA science missions.
We have some video of the Delta II that's being used for tonight's launch, and kind of talk to us through this footage. What's going on here?
Now we're looking at the payload fairings that are being taken out to the launch site and being hoisted up into the tower. There's the mobile service tower at the very top has a white room, which is a clean facility that's for processing the fairings and the spacecraft right before it is put onto the rocket. So now we're looking at the first stage that's been hauled out to the base of the tower, and the guys are rolling the transporter as the crane lifts the rocket up, and the crane in the mobile service tower will lift the rocket until it's erect, and then move it in and set it down on the launch mount, and they'll actually bolt it down to the launch mount. And so what we're looking at here now is the inner stage was being lowered down, and that's basically an empty can that allows for the receiving of the second stage. Now we're looking at the solid rocket motors. There are 3 on this mission that come in one at a time, and again the guys are using the dolly and the crane to hoist those to vertical and then lift them in and place them one by one and bolt them to the side of the first stage. And here we're looking at the bottom of the second stage engine just as it's getting lifted up into the tower, and then it'll be brought into the tower and lowered into that inner stage kind of empty can piece that's at the top of the first stage that receives that second stage engine. And now we're looking at the spacecraft arriving. So this is OCO-2 and its shipping container having been trucked in from Arizona. This is late April time frame. It's being backed into the processing facility that's also on Vandenberg, not far from Slick 2. Of course, it was bagged in its shipping container. They're removing the bag now, and they're going to be. This is the very beginning of a couple-month-long process of preparing the spacecraft, testing the spacecraft, final installation, final preparations. Here we see it being loaded onto the work stand and actually depressing the separation springs that will be used at payload separation that will push the spacecraft away from the rocket. Now we're looking at the pedals of the transportation can that are being installed around the base of the work stand. That forms the bottom of the can. You see the top of the white cylindrical can that's being lifted by the crane. It's being brought over to the top of the spacecraft and lowered down onto the spacecraft. That'll complete a can that's a protective transportation container for the spacecraft as it goes out to the pad on this transporter. Here, this is about June 14th, I believe it was. In the early morning hours, the team rolls out of the processing facility.
Foggy, it looks like once
Foggy,
again.
yes, good old Vandenberg weather,
All right.
and not disappointing. And the can goes out to the base of the mobile service tower. Again, they drop the hook from the MST crane, pick that can up off the transporter and lift it up into the tower and set it down on the top of the rocket, bolt that down to the rocket, and remove the transportation can.
Gotcha.
And so now we're looking at the fairings, the payload fairings being brought around the spacecraft. They close those fairings, the two halves of the fairings around the spacecraft, and that provides that protective aerodynamic shell at the top of the rocket to protect that spacecraft during the first 5 minutes of flight.
Now, how many? I mean, that seems like that's a lot of work.
Yes,
to go into a line.
You bet.
I like that resident manager. I mean, because you're the man here. I mean, you're the man in charge.
Yeah,
you make
try
it
to keep things running.
Well, John, thank you so much for being here.
My pleasure.
And your hospitality has been generous, and thank you for all the logistic support that we needed here on the show.
You're welcome.
What we're going to do now is we're going to turn our attention to the science aspect of OCO-2. Blair was at JPL and had a chance to talk with project manager Ralph Basilio.
We're here at the Jet Propulsion Laboratory talking to Ralph Basilio, who's the project manager for OCO-2. Ralph, we're very excited to be here for the launch, and I'm just really excited about OCO-2, but I was wondering, can you tell me, what is OCO's primary mission?
Well, the science mission for the Orbiting Carbon Observatory-2 is basically to get retrieved estimates of atmospheric carbon dioxide, precise measurements of CO2. Because we want to be able to fundamentally be able to identify what we call emitters of CO2 and also absorbers of CO2, what we also call sources and sinks. We know that we have about a 60-year data record that strongly suggests that about half of the CO2 that's being emitted through human activity, specifically fossil fuel emissions, stays in the atmosphere, but the other half is being absorbed somewhere. Maybe it's the northern boreal forest, maybe it's the southern oceans, but we're trying to find out where these sinks are of atmospheric CO2 so that we can better understand, better study those sinks of CO2. Some other fundamental questions that we have with these sinks are, what's going to happen over time? Are these sinks going to become less efficient? Are they going to become saturated? Is more CO2 going to stay in the atmosphere because of that? And is that going to further accelerate the global climate change process? These are some of the very fundamental questions that we want to be able to answer with the Orbiting Carbon Observatory-2 mission.
This is an amazing amount of data you're trying to acquire, and I'm wondering, how long will OCO-2 have to fly in space to accomplish its mission?
Well, the nominal or normal mission is 2 years. It's 2 years because we want to be able to see seasonal variations. And as you know, the normal cycle has CO2 concentration levels varying as, for example, plants die, plants grow, and we want to be able to see that trend. But we also want to be able to see a longer-term data record. So 2 years is the normal mission or nominal mission. Now, we really hope that we're going to be able to have an extended mission and maybe have a 5-8 year mission.
And that's sort of that built-in conservative
Yes,
approach,
that's
right?
correct.
Because
Yeah.
we have a track record of having these satellites up there much longer.
That's correct. We have a very good track record. I worked on a project called CloudSat many years ago, but just this past April 28th, 2014, we celebrated our 8-year anniversary in space. And that mission was only designed to operate for a few years, so it's still doing its thing, collecting
All right.
data for us.
Some people are going to start asking questions about how conservative you actually are, because you're getting some really good lifespan on these
that's
missions.
right. Yeah.
But I know you mentioned CloudSat, so obviously OCO-2 is flying with other satellites. I believe
That's
the
correct.
A-Train.
Yes, so CloudSat and other satellites are flying in what's called the EOS, or Earth Operating System Afternoon Constellation, or A-Train for short. And once OCO-2 is launched into space, we are going to maneuver the satellite or observatory up into the operational altitude and basically be the front or lead for this constellation of other satellite systems.
Was there some internal controversy about taking the driver's seat?
Oh, no. It was basically, we are following the same concept that we developed on the original OCO mission. So this mission was originally conceived of in, I think, 2002. And we launched the original OCO mission in February 2009. Same science objectives. Well, unfortunately, we did have a launch vehicle payload fairing anomaly that prevented the observatory from being placed into proper Earth orbit. It basically fell out of the sky, burned up, and it was lost. And so we had been working with our NASA sponsors, working with the administration since 2009. And in March of 2010, we got the official go-ahead to develop the rebuild, which is now called Orbiting Carbon Observatory-2. And we're quite fortunate because we feel that the scientific measurements that are going to be obtained from the OCO-2 mission are not just important, but there's also a sense of urgency. It was just recently reported in the last year that CO2 concentration levels are now at 400 parts per million. Unprecedented, unheard of in the last 800,000 or more years. So something is obviously happening with the atmosphere. And we talk about maybe different ways to solve problems, but the primary goal for OCO-2 is just to obtain the data, get the information so that we can better understand what that problem is all about.
So, Anne-Marie, as I understand it, OCO-2 is NASA's first dedicated satellite to study carbon dioxide emission, and I'm wondering, how does the science work for OCO-2?
The science for OCO-2 is really about this big question that we have about where carbon dioxide goes. We have a really good understanding of the carbon dioxide that we emit from burning fossil fuels. If you think about your gasoline and jet fuel and heating oil, it's all bought and it's sold and it's taxed. And so people know where it's coming, where it's going. But humans right now, we emit a large amount of CO2 from these fossil fuels, and we know how much that is. And we have a few places on the globe, like you've maybe heard about the Keeling curve from Mauna Loa. There's a place where there's an instrument on the ground measuring carbon dioxide, and it sees the seasonal changes and it sees the growth over time. But when you do the math and you say how much new carbon dioxide did we see this year from that measurement and how much did we emit from burning, there's a mismatch. Some of it's gone, and it's, where did it go? So what's happening, we think, is that like half of it stays in the atmosphere, but half of it is actually interacting with other parts of the Earth. The oceans actually can dissolve carbon dioxide, and we think that the plants and the oceans take some of the carbon dioxide that we emitted from the fossil fuels. But there's still big questions because every year the amount they take up is a little bit different. So I say the oceans take it up, but which oceans? Is it the Pacific, Atlantic, Southern Ocean? So those are unanswered questions. So that's the science that we aim to answer with OCO-2.
Obviously, it's very important that OCO get this data, but you can't seem to get it from any of the other satellites that are flying. What makes OCO unique in that sense?
Yeah, so we're excited about OCO-2 because it's NASA's first mission that's really just dedicated to measuring carbon dioxide, and it was designed in a very specific way. So carbon dioxide is what we call well mixed. Like on average, the concentrations don't have huge gradients, not the way some other pollutants do, where you can change by an order of magnitude from one spot to another. Carbon dioxide is relatively well mixed. So to answer these sources and sinks questions, you need to be seeing everything in the atmosphere. You need to see the stuff near the surface as well as the stuff high up. And so we picked a wavelength of light, which is about 2 microns. It's longer than what you see, but it's only about twice or 3 times as long as what you see. And that has the right sensitivity that we'll see the carbon dioxide all the way in the atmosphere. There are some other CO2 measurements, like there's some instruments that were built for weather or for pollution, measuring at very long wavelengths we call thermal infrared, 10 microns compared to our 2. And they have sensitivity really to the higher parts of the atmosphere because of some of the physics that are going on. They're blinded near the surface because there's not enough contrast and temperature, but they're sensitive above. So they learn about some of these long-range processes, but they can't see that much about what's happening with that exchange with the surface.
Now, how is that total picture, that total column? How are you going to use that data to make these, draw these conclusions about carbon dioxide?
A good question. So what will happen is every day we're flying OCO-2 around the Earth. It goes around about 14.5 times a day. And we're looking down and collecting data, and we'll actually have about 1 million spectra that we collect every day. In the orbit that we're in, it's a sun synchronous and it repeats. So after 16 days, your orbit is exactly where it was before. So when I think about this, I always think kind of in 16 days of data, because in 16 days you get a full picture of the Earth with about 150 kilometers between one set of measurements and another. So it gives you this kind of sampling of the globe. We call ourselves a sampling mission, not a mapping mission, because we don't get you a picture. I can't show you a map of California with measurements all over it. So we'll have this data set, but then when you think again about carbon dioxide, it has these sources and these sinks, so it's exchanging with the atmosphere, but what else is going on? Well, the winds are moving all of this stuff around the globe. So I need to be able to think about all of those processes and what that means to the carbon dioxide I measured. So in the end, we usually work with this data with global modelers. So there's modelers or scientists who represent the exchange of carbon dioxide and the transport in the atmosphere through their models. So they get all of the physics in the model, and then we provide them with some measurements of the carbon dioxide that can be compared with the model data. So it's very hard to interpret our data alone because transport's also playing a big role. So really when you say, where's the carbon go? I won't tell you that myself, but in collaboration with those modelers, we're going to answer that question.
Well, I'm just wondering if you can tell me whether or not we're going to get some carbon credits back for flying OCO-2.
I don't know. If you do the math on all the energy we burn, I'm not sure we're in the carbon credit world, but I'm driving my Prius and trying to cut down on my fossil fuel burning.
Who knows? We might find a better way to determine that carbon footprint if we understand this exchange better.
Exactly.
Mike, I'm very excited to learn more about OCO-2 and the data that it's getting. So
just right there, we've got to get it right. I mean, it's OCO, because every good chemist knows it's oxygen, carbon, oxygen, orbiting carbon observatory. So high school chemistry says we should call it OCO, just as first principles.
Okay, fair enough. But your colleague, Anne-Marie, she's much more forgiving. Is it okay to say OCO-2 as opposed to OCO-2?
It's an East Coast, West Coast thing. Okay. We hear OCO-2 out east, and here on the West Coast we say OCO-2.
East Coast, West Coast, that's great.
we can't account for the poor education system on the East Coast. We've got to go for the...
Wow. All right, well, you know, I tell you what, I'll make a compromise. I'll go with OCO if you can get them to change the loco, because shouldn't it technically be subscript 2?
Yeah, I think we need to get the whole redesign going and make sure that everybody understands it's really chemistry here.
All right, well, fair enough. I tell you what, we'll work that out later and get to the science now. A lot of missions that we know and a lot of satellites we have deal in raw data, but everything I've read about OCO-2 is that you'll be using assimilated data. What exactly does it mean to use assimilated data?
So we're all used to the weather forecast, and that's all based on getting data from weather balloons released around the world and satellite data. And that's taken into a weather model. They use a mathematical process called data assimilation. When that data is ingested through data assimilation, then they can let the model run forward and give us a 1-day, 5-day, 10-day, month-long weather forecast. But our raw data, we transform it into measurements of the concentration of carbon dioxide. And it's that measurement that then gets ingested into models to learn what's going on at the surface through data assimilation.
I see. So in other words, you do collect raw data, but in terms of how it's used, it will be used in cases with assimilation.
That's right. That'll be one of the very important tools that many of our colleagues in the science community have been developing, so that be ready to take our data, the raw data that we'll provide, so that we can do that underlying science.
Well, that's just one of the things that I thought was interesting, because I also noticed that you've got one primary instrument looking at this column, but you've got some different modes that you can use.
So we make measurements all the time in reflected sunlight. So we're looking at the light from the sun hits the surface of the Earth and then is reflected out back to the satellite and the instrument. But in parts of the Earth we can do that over land, which is typically kind of bright. We can do that by pointing the instrument and looking straight down at the surface. But over the ocean, if many people if they've flown in an aircraft over the ocean and looked down out of the windows, the ocean looks dark. That's because when you look straight down at the ocean, not much sunlight is reflected up. It's really all absorbed into the ocean. But we're very fortunate that in actual fact there is a point on the ocean surface at a certain angle that you look at where you can see the bright spot of the sun. So that's called the glint spot. So to get data out over the oceans to complete the global picture, we'll point the observatory to that glint spot for 16-day sections actually, so that we can sweep our observations out over the global oceans. We have a third mode, because this is one of the most difficult measurements to make of an atmospheric gas at something like 0.25% uncertainty. We have to be very careful about calibrating and validating our measurements. So to help us do that and keep us on track with our calibration and validation, there are ground sites around the world where people are making very careful measurements and that are comparable to the ones we will make from OCO. So we have another mode to help us get these detailed inter-comparisons where we allow the observatory to look ahead at a ground point where one of those ground measurements are being made and track it for several minutes so that we get thousands of observations nearby. That'll give us the insight into how the measurement is working and whether there are any bias or uncertainties creeping in that we must account for in helping the science community use the data in understanding what's really going on globally at the surface.
This is very exciting. We can't wait to see OCO-2 fly and start to get these data streams, and hopefully we'll learn more and more about carbon dioxide and what it means for us here on Earth.
We sure will. I'm really excited about the prospect of seeing a good launch, getting to orbit, and a data stream.
5, 4, 3, 2, engine start, 1, 0, and liftoff of the Delta II rocket with OCO-2, tracking a greenhouse gas in seek of clues to climate change.
Franklin, what another great launch for the Delta II.
Yes, it was a beautiful launch, and it was a great show. We'd like to thank all of our guests who joined us today, especially Administrator Charlie Bolden.
And all the folks here at Vandenberg Air Force Base to make this show possible.
If you want more information on the OCO-2 project, go to nasa.gov. You're watching NASA Edge, an inside and outside look
At all things NASA.